All right, what up, everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about motion maps. Now, first of all, what is a motion map? A motion map is a still picture that shows something in motion, right? And let me give you an example. If you look at the car up on the top of the screen, this car is going to drive through the screen at 2 meters per second, all right? And each of these numbers represent another meter. So 1 second, 2 seconds, 3 seconds, 4 seconds, and then it's gone. All right, so we all just saw that car move, so we kind of know how it moved. But let's say we wanted to make one still picture that showed someone else how the car moved, so that if a person saw that picture, they would be able to figure out how fast the car was going, what direction it was going, and so forth. All right, so one thing we could do is we could have the car drive by again, and this time we're going to take pictures with a special camera. And what this special camera does is that it leaves a picture of the car on the screen and then takes a picture of the car the next second, 1 second later, leaves that picture on the screen. 1 second later, it'll take a picture of the car again and leave that picture on the screen. So here's after 1 second, 2 seconds, 3 seconds, 4 seconds. Right? And so if you had that picture and you knew that one picture was taken every second, you could kind of figure out which way the car was moving and about how fast it was going. So that's the idea of a motion map. Now, here's how we'll draw motion maps. If you look at the bottom of the screen, instead of drawing a car every time, we're going to draw a dot, and that dot just represents an object. Right? So if this is a car, you draw a dot. If it's a dog, you draw a dot. If it's a person running, you draw a dot. Right? That saves time. Okay, and I drew a dot on the location on the screen where the front of the car was. Right? So in the beginning, the front of the car was lined up right at 0. The dots lined up right at 0. 1 second later, the front of the car is lined up at 2. The next dot is lined up at 2, and then you can see that that pattern goes on down the line. Next step is to draw an arrow from the dot that goes almost all the way to the next dot, just like that. Because the car was moving to the right, we draw the arrows pointing to the right as well. Okay, so that's what the motion map looks like. Now, why would this motion map be important? Well, there are some things that we can see about the motion just from looking at that map. So if we had never seen the car go by, we could look at this motion map and we could tell how long it was driving by the screen, okay? Because every second a new dot is put on the motion map. So you can see that it started at 0 seconds, then 1 second, 2 seconds, 3 seconds, 4 seconds. Right? So the number of dots tell you the number of seconds. The length of the arrows tell you the velocity of the car. So if this car is going very fast, the dots would be far apart and you'd have a long arrow in between them. So that would tell you a long arrow means the car is going fast. If the car was going slower, then the dots would be closer together and the arrows would be shorter. So a shorter arrow tells you that the car was going slower. We can also see the pattern of motion because these arrows are not changing size as we go from left to right. And that tells us that this car was going at about a constant velocity. Right, so we're going to see more motion maps as the course goes on. Until then, enjoy your studies. I'll see you later.